Hello. Today in this video, we will be looking at a Chapter 5 problem, problem 52. The problem asks us if sine of t is equal to 3/8 and t is in the second quadrant, find cosine of t. Remembering from the unit circle, we can draw a coordinate plane. The second quadrant is right here. The first step in approaching this problem is drawing a right triangle. But as we can remember from the unit circle, it is built upon the idea of sine of an angle being the y value and cosine of an angle being the x value. So we can draw a right triangle. We also can remember that the definition of sine in a right triangle is opposite of the angle over the hypotenuse. This fraction looks very similar to up here. So we can say that sine of t is equal to 3/8, which is up there. And looks very similar to opposite over hypotenuse. So from this angle, the opposite of it is 3. And the hypotenuse of this right triangle, just across from the 90-degree angle, is 8. Now before moving on, it's important to note that since cosine is the x value of this coordinate, and sine is the y value, when we're in the second quadrant, the y value is positive, but the x value will be negative. So it's important to note that our cosine of t will result in a negative answer because, based on our coordinate plane, x is negative in the second quadrant. So let's now talk about the right triangle definition of cosine, which is cosine of an angle is equal to adjacent of the angle divided by the hypotenuse of the triangle. Now if we look here, we don't actually have a direct side length for our adjacent side. So we can label that as b. And using the Pythagorean theorem, we can solve for b, because we know that a squared plus b squared is equal to c squared. A squared is our 3, and c squared is our hypotenuse, which is 8. So we can solve for b, and we can say that b is equal to the square root of c squared minus a squared. Then we can substitute in the values from our right triangle. B is equal to the square root of c squared, 64, a squared, minus a squared, which is 3 squared, minus 9. So we have b is equal to the square root of 55. Now that we know that b is equal to the square root of 55, we can then use our definition of cosine in a right triangle, which is adjacent over hypotenuse. Actually, before we go to that, let's remember that cosine of theta, which is x, will be negative in the second quadrant. So this is actually not just square root of 55. It's negative root 55 because we're in the second quadrant and x is negative in that quadrant. If we plug in these values, the Pythagorean theorem still works because negative root 55 squared is 55, which is positive. So now that we know that, and we know that b is actually negative root 55 because it is an x value in the second quadrant, we can then use our definition of cosine in a right triangle, which is cosine of theta, or an angle, of any value, is equal to the adjacent over the hypotenuse. Right here, the adjacent is negative root 55, and the hypotenuse is 8. So our final answer is negative square root 55 over 8. And remember that it's negative root 55 because the x value, which is cosine, in the second quadrant is negative. So cosine of t is equal to negative root 55 over 8 if sine of t is equal to 3/8 and t is in the second quadrant. Thank you for watching.